Hello all my dear students in grade 12 advanced stream academic year 2024-2025 term 2. Today we will talk about chapter number 6, direct current circuits. Section number 1, Kirchhoff's rules. Our learning objectives: explain Kirchhoff's junction rule, explain Kirchhoff's loop rule, analyze circuit using Kirchhoff's loop rule. Keywords: junction, loop, DC circuits. The main idea to study Kirchhoff's rules that some circuits are too complicated to analyze. None of the elements are in series or parallel. Kirchhoff's rules are very helpful to analyze a circuit, means to find potential difference across each component and the current in each component. Firstly, we will start to study Kirchhoff junction rule. Sigma I in equal sigma I out. That means the sum of the charges comes from the battery entering a junction must equal the sum of charges in the two branches. What is the meaning of junction? A junction is a place in a circuit where three or more wires are connected to each other. Each connection between two junctions in a circuit is called branch. This is two junctions, it's called branch. Each branch can have current flowing, and this current is the same everywhere in the branch. As you see, 0.8 ampere equal to 0.4 plus 0.4. That means the entire current equal the out current. Kirchhoff junction rule states that the sum of the current entering a junction must equal the sum of the current leaving the junction. And the mathematical equation for the junction rule is sigma I equal 0. Kirchhoff junction rules, in other words, for a junction, the law of conservation of charge requires that summation current in equal summation current out, or sigma in equal sigma I out. In like I1, I out like I2 and I3. So junction law, I1 is equal to I2 plus I3. At any junction point, the sum of all currents entering the junction must equal the sum of all currents leaving the junction. Now let's talk about the second rule, Kirchhoff loop rule. For any path that starts and ends at the same point, closed path, the energy supplied by the battery equal the energy dissipated by the two resistors. VEMF is equal to VEMF for the battery is equal to V1 for the first resistor plus V2 for the second resistor. The sum of all the potential difference encountered while moving around the loop, closed path, is 0. Now let's talk about Kirchhoff loop rule. For any path that starts and ends at the same point, closed path, the law of conservation of energy requires that summation delta V equal 0. That means summation all potential differences around the loop, closed path, is equal to 0. Now, we need to learn how to calculate the delta V's. Let's start with a battery or any position, like this is a start and end position here. You know, if we start from here, we will rotate around the loop and we'll come back here. This is a closed loop. Okay, then add the potential differences around the loop. So we will find that delta V1 plus delta V2 plus delta V3 plus delta V4 equals 0. And this is a closed loop. So the sum of all the potential differences encountered while moving around a loop or a closed path is 0. Kirchhoff loop rule then states that the potential difference around a complete circuit loop must sum to 0. Summation VEMF minus summation IR equals 0. And summation EMF, that means summation for potential difference in all power supplies or sources minus summation EMF or summation potential drop in all resistors or all loads in the circuit is equal to 0. And if you see in this video, on this picture, we can determine the direction of delta V in the resistor by this base delta V in the resistor if the resistor is the same direction of the loop, so delta V will be minus IR. And if the current in the opposite direction, delta V is equal to positive IR. And in the battery, if the loop directed from negative to positive, then delta V will be positive VMF, but if the opposite, it will be negative VMF. And now let's talk about delta V across a battery again. For an ideal battery, and according to a property of the battery in the negative position direction, and according to travel direction, the negative is the lower voltage, and the positive is the higher voltage. And we suppose this is an initial position, initial point, and the positive is the final point of the final position. So the loop direction is from negative to positive terminal. Then delta V is equal to V final minus V initial is equal to V final is V positive minus V initial is V negative is equal to positive value, and then delta V will be positive EMF. Then for a battery, the potential difference is positive if your choosing loop direction is from negative terminal to positive terminal. From negative terminal toward the positive terminal, so the potential difference for the battery will be positive value. And in the opposite case, for an ideal battery, and according to a property of the battery, in the positive to negative direction, from the positive terminal to the negative terminal, you know that the higher voltage is the positive terminal and the lower voltage is the negative terminal for the battery. And according to the traveling direction from positive direction, initial point, to negative terminal, then the direction of the loop from positive terminal to the negative terminal. So delta V is equal to V final negative minus V initial positive. That means it will be negative value. Then delta V is equal to negative EMF. Generally, for a battery, the potential difference is negative if your choosing loop direction is from positive terminal to negative terminal. If you move from positive terminal to negative terminal, then VEMF will be negative value. On the other side, let's calculate delta V across resistor. For a resistor, apply Ohm's law. The potential difference is negative, decrease, if you choose loop direction is the same as the choosing current direction through the resistor. Then we suppose that this the higher voltage and the other side is the lower voltage. So we suppose that the current direction will be from positive terminal to negative terminal. So the current will be to the right. If we took the loop from left to right, then the loop direction will be directed to the right in the same direction of the current. So delta V will be V final minus V initial, V final minus V initial, negative minus positive. So the value will be negative. Then delta V by applying Ohm's law is equal to minus IR, and the potential decrease. And in the opposite case, for a resistor, applying Ohm's law also, the potential difference now is positive increase if your choosing loop direction is opposite to the choosing current. So if you choose the current to the right and the loop direction to the left, so delta V will be V final positive minus V initial negative, and the result will be positive value, and delta V is equal to positive IR according to Ohm's law, and the potential will increase.